So yeah, voltage across R2 would be power divided by current.
Which is 1604.89.
Okay? Oh, that's K, by the way. 1.6 K volts. And what is the resistance of R2? Basically, to be the 1.6 K volts divided by the 617 milliamps. .5 K.
599, yeah.
Yep. 2.599, yeah. Or we'll call it 2.6.
2.6.
2.6. I think the answer sheet has 2.6, yeah. Okay? So, let me see. Next is R4. Let's do them a little different, right? Let's figure out his voltage a little bit different. Let's use Kirchhoff. We know if we start out with 5,000 volts, right? And R3 is going to drop 1.9136 K. How much is left for R4? It'll be 5 K minus 1.91 K. .086 K. 864. And the thing about it is, if we done it the other way, we divided our power by our current, we'd basically be dividing 3.0864 K by 1, which has been 3.0864 K, right? Says, Jim, why is R4 1 amp again? Oh, the reason R4 is 1 amp is because all the current goes through R4. And the problem stated you have 1 amp total current. So 1 amp leaves here, it's going to split, recombine here, and then all of it will go through R4 again. So R4 is in series with the total current. So the last thing that they record is resistance of R4. It'll be 3.086 K. So now, we had some issues with this number not being correct to start with, right? Going, man, how can that be? So let's go ahead and calculate total resistance using these values we calculated, right? So we know R4 is 3.086 K. So this whole branch here has to be 5 K minus 3.086 K. So 5 minus 3.0864 is 1.913 K. So this branch here would have to be 1.913 K for this 5 K to be right. You guys see that?
1.914.
Okay. So let's go ahead and calculate it out. So first, we add R1 to R2. So 500 plus 2.6 K, that's 3.1 K. And that's in parallel with R3, which is 5 K. So that's 1 over 3.1 K plus 1 over 5 K. And that should equal 1.913 K. Cool. So, 5K is right. Darren, do you see the R4 1 amp guy? Or any questions about how I work this guy?
No, I mean, that was pretty... Yeah, once you make that little chart like that, it makes it pretty good.
Okay. So, yeah, if you need to make a chart on your test, make yourself a chart. Because, yeah, it helps you to remember what everything is. And then, by looking at your chart, you can deduct other things just by looking at the chart.
Yeah, exactly.
Okay, let's do another one. That was number 6. How about number 7?
Sounds good. Let's do 7.
All right, 7. Ooh, 7 looks a little rough. Ha! Okay. I'll redraw it here.
Yep, get a little circuit going.
Yeah. Okay, R1, R2, R3, R4, and R5. Okay, so let's make a chart here. Total R1, R2, R3, R4, R5. Voltage, current, resistance, power. And we say voltage total is 12 volts. Current through R1 is 3 milliamps. Current to R2 is 1 milliamp. Current to R3 is 1 milliamp. Current to R4 is 1 milliamp. What I was thinking here. And current to R5 is 1 milliamp. And R1 is 2K. That's all they give us? Huh. Alright. We can do this. Okay, so let's see if we can calculate total current. If we have 3 milliamps through R1, what is our total current? It would be 3 milliamps, right?
Yep.
Yep, exactly. So if IT is 3 milliamps and VT is 12 volts, what's total resistance? It would be 12 volts divided by 3 milliamps. Yep, 4K. All right, so also take a look at this. R2, R3, and the combination of R4 and R5 are in parallel with each other, right? So
Yeah.
if you have the same current through R2 and R3, what does it say about the resistance values? They'll be the same. Also, the resistance values of R4 plus R5 will equal the resistance value of R2 or R3. Right? Because they have the same current. Okay, let's go ahead and calculate some stuff. How about R1? Let's calculate the voltage drop across R1. So that'll be 3 milliamps times 2K. They can be
Okay.
6 volts.
6.
Okay, so if 6 volts is dropped across R1, and our total voltage is 12 volts, how much is dropped across R2?
6.
Yep. How much is dropped across R3? Be 6. Now R4 and R5, we have to figure that out. Because they both will have 6 volts, but we got to add them up to 6. Okay? So how about some resistance values? If R2 has 6 volts and 1 milliamps, he must be about a 6K resistor. So it'd be 6 volts divided by 1 milliamp, 6K. Now, R2 is going to be the same thing, another 6K. Ooh, I don't know if I gave you enough information. I don't think I gave you guys enough information to solve R4 and R5. But here's the thing. I'm going to say R4 is 1K. Okay?
R5?
Yeah, R5 is 1K.
Okay.
So if R5 is 1K, how much voltage does R5 drop?
1.
1 volt, yep. Which means R4 is going to drop how many?
5.
5.
1.
Right, 5 volts, right?
Right. Yeah, for R4, because it has to equal 6.
Yes. So what's going to be the value of R5, resistance value?
Okay.
5K, that's right. So basically we have 3 6K resistors in parallel, right? R2 is 6K, R3 is 6K, and the combination of R4 and R5 is 6K. So 3 6K resistors in parallel gives us a total resistance of 2K, plus R1 being 2K, add up 4K total resistance. So basically 1 over 6K plus 1 over 6K plus 1 over 6K gives us 2K. So 2K for all of these plus this 2K in R1 gives us a total resistance of 4K. Any questions of how I got that one? Then power, we could do that, whatever. Voltage times current, 1 volt times 1 milliamp, that's 1 milliwatt. 5 volts times 1 milliamp, that's 5 milliwatts. 6 milliwatts, another 6 milliwatts. 6 times 3 is 18 milliwatts, and that's 36 milliwatts. So 36, so 18 plus 6 plus 6, and 6 should equal 36. Are you guys getting the hang of this? Because, I mean, this is all about Kirchhoff's current law, Ohm's law, the parallel and series stuff working together. It really helps me to, like I said, to do this chart and to trace out the stuff and see, because a lot of times what they give you one thing, but they also give you other things too, just by knowing which way the current is flowing in the circuit. Okay, which one was that? That was number 7.
7, yeah.
Let's do number 8. Okay, the same circuit. Okay, number 8. Voltage across R1 is 17.28. Current through R2 is 14